for adding and subtracting polynomials, first we need to cover a little bit of vocabulary. On this first slide we see degree of a monomial. First off, monomial is just a type of polynomial. Poly means many. If we want to get more specific, we use different prefixes. Mono meaning one, meaning basically we're looking at a single term. So all these four examples down here are just different single monomials. Now, what we're going to talk about today is what's called the degree. The degree of a monomial is basically, I like to think of it as how the degree of difficulty, how complicated is this problem going to get. So we tell that by the exponent. Basically, all you have to do is look at the exponent that's attached to the variable. So like 7x squared, or 7x to the second power, has a degree of 2. But then if you have a different monomial with two exponents, what you do is you add them together. 2 plus 4. So this monomial has a degree of 6. Now, what if you have the variable all by itself? Negative 2f, no exponent. Well, we should remember from previous units that there's always a 1 there. It's usually just an invisible one we don't bother writing, but it's there. So this has a degree of 1. And then for this last one, 3x y to the first. Again, if there's more than one exponent, we add them up. So 3 plus 1, this has a degree of 4. So this is how you find the degree of a monomial. Okay, but what about more complicated problems? Let's say these. Let's take a look at the degree of a polynomial, meaning something that's going to be more than just one monomial. So if we take a look here, we've got this monomial, and then there's a subtraction sign. You can always tell what separates the different terms or monomials by looking at the addition-subtraction sign. So in this case, there's a subtraction here. So this is a separate monomial. There's an addition sign, and then another separate monomial. So there's 3 monomials, which makes this a trinomial. Now, for the degree here, we don't add the exponents like before with monomials. What we do is we look at each individual monomial. In this case, we have a degree of 3. This one has no variable at all, so you want to think of this as 2x to the 0 power. So this has a degree of 0, and then this one 3x to the 4th, so we have a degree of 4. Now of those 3, we take the highest. 0, 3, and 4, the highest degree here would be 4, so the degree of the entire polynomial is 4. Take a look at the next one. P to the 5th, 7p to the 1st, 4p to the 3rd. Of those 3, the highest one, the 5, so this has a degree of 5 for the entire polynomial. Then finally this last one, negative 2f to the first power, 7f to the third power, f to the second, and then 8, so 8f to the 0 basically. Of those 3, the highest one is 3, so a degree of 3. Now, before we move on to the next slide, let's talk about standard form. Standard form is basically looking at the degree of each of those monomials and then rewriting it just so that it's organized. We organize all our problems in the same way. So, for example, if I were to take this problem right here, to reorganize it in what we call standard form, what I want to do is I just want to order each of the monomials according to their degree, with the larger degrees first and then working to the lesser degrees. So in this first trinomial here, what I would do is I would take my plus 3x to the 4th, or positive 3x to the 4th, and I'd put that up front. Next, in terms of degree, would be this one, 5x to the 3rd, so plus 5x to the 3rd, and then this degree of 0, which is the minus 2. And so it's the same trinomial, it's just we've written it in a different order, which is called standard form. Let's try this one. Put this one into standard form. The one with the biggest degree was p to the 5th. Next would come minus 4p to the 3rd. And then finally plus 7p. p to the 5th, p to the 3rd, p to the 1st. Everything ordered according to its exponents from greatest to least. Alright, and then finally this one down here, we've got, let's see, positive or plus 7f to the 3rd, minus f to the 2nd, minus 2f, I'm running out of space, so I'm just going to put it down here, plus 8. Okay, so now you have a bit of vocabulary. We've got how to find the degree of each individual monomial. We know how to find the degree of the entire polynomial. And we know how to put polynomials into standard form. So let's take a look here. Now, with these things we call degrees, we actually have certain names that go with them because specifically when we graph them, we start to see certain things. So if I take a look here, if I have just a plain old number 4, or like let's say it's 4x, it's like 4x to the 0 power. So there is actually no variable at all, because anything to the 0 power is 1 and essentially just disappears. So it has a degree of 0, which we have a name for it. That's called a constant, because since there's no variable, the number is just a plain old number. It's constant. It doesn't change. 4 will remain 4 throughout an entire problem because there's no variable attached to it which can change it. Now, as we go up, here we've got 3x plus 2. Again, our highest, our highest degree here is 3x to the first power, so it has a degree of 1, which anything to the degree of 1 we call linear. And if you think about it, that makes sense, because in the units where we did linear functions, this is exactly the type of function we have, 3x plus 2. 3 is the slope right next to x, plus 2 would be our y-intercept, and we always got linear graphs when we did those. Then we start getting into stuff we're going to start seeing now. X squared minus 4x plus 7, our highest degree is to the second power, so it has a degree of 2. This one we call quadratic. And to me, this is the only one that I have a hard time remembering, because quad, I think 4, but it's actually a degree of 2. So of all the ones you kind of have to not get tricked by, it's this one. A degree of 2 is what we call a quadratic. And as we go up, we just have other names. In this one, 5x to the third plus 1, degree of 3, we call it cubic. And that kind of is easier to remember because x cubed, or cubic here. But after that, we don't have any specialized names for them. We just start going up. This one's 2x to the fourth minus 3x plus 4, so a degree of 4. We call it a 4th degree polynomial. So if we go beyond that, it's a 5th degree polynomial, 6th degree polynomial, and so forth. Okay, finally, we have another way to name polynomials, not by their degree, but by their length, by the number of terms that they have in the polynomial. So let's take a different look at polynomials. Let's say I have something like this. So forgetting about the degree of 3 here, what we're really looking at now is 2x to the third. Okay, it's no pluses, no minuses, so it contains all the things as one term. You don't think that this is 3 separate numbers. It's 2x to the third. It's a single term, or what we call a monomial. And then as the problem gets longer, separated by those plus and minus signs, we rename them. 3x plus 2. So here we've got 2 monomial terms. Well, 2 in this case, bi, meaning binomial. Here we've got a trinomial. 1, 2, 3 terms, again separated by the minus and plus signs. And then after that, again, we don't have any special names for them, just for the first 3. After that, we just start calling them 4-term polynomials, 5-term polynomials, and so forth. So basically what we've run through here, and go ahead and copy this down in your notes, is that a degree of a monomial is the sum of all the exponents in a single term, where we just take that single monomial, we look at its exponents, and we add those exponents up. The degree of a polynomial, though, is done a little differently. We look at the degree of each of the monomials, and we take the degree of the term with the highest exponent. So it's not about adding anymore, it's just about looking at the problem and which of the terms has the highest exponent. That becomes the degree of the entire thing. And then finally we have standard form of a polynomial, which is just to order the terms from highest to lowest degree. It's just a standard way of writing it so that everybody does it the same.